Welcome back, everybody. So we're going to continue on talking about variations of the epidermis, and we're still focusing on coloration due to different molecules. So we talked about hemoglobin and melanin in the last video. We're going to finish up talking about carotene in this video. Carotene is the active form of vitamin A. It is a fat-soluble vitamin, and when you have an overdose of any fat-soluble vitamin, you can't just release it through urination like you do with water-soluble vitamins. Fat-soluble vitamins will actually sit in fatty tissue and can cause intoxication of that vitamin. In this case, intoxication is only going to lead to a yellow-orange pigment on the skin, so it's not so bad. But there are some vitamins that can be very dangerous when you have too much. So vitamin A, or carotene, is really important in helping us to see. So vitamin A is needed to produce the pigment molecules for vision in our eyes. It also helps in our immune system in fighting off potential pathogens, in helping our cells to be stronger, and it reduces free radicals. A free radical is an atom or a molecule that has lost an electron. And because it's lost an electron, it is no longer stable. And in that case, it becomes, I can't think of his name, SciShow Man says, it becomes a rogue character. And it's going to attack or bond to all parts of the cell, including the cell membrane, which will then cause problems with the function of the cell membrane. It can bind to the nucleus, cause damage, and so it can basically kill cells or lead to aging of tissues and also potentially cancers. And so vitamin A is really important. You get vitamin A from those yellow-orange vegetables like carrots, squash. They have a lot of carotene in them. And so here's what an antioxidant is. So here's a good molecule, and here is a free radical. So this good antioxidant gives this free radical an electron, and when it does that, the free radical no longer is rogue. It's all of a sudden very happy, and it's not going to do any damage. That's what an antioxidant does, and that's what vitamin A acts as in our cells, or in our body. Vitamin A also is very important in sight. So in some countries where they don't have all the nutrients they're supposed to have every day, vision can become very impaired to the point of blindness, not because of anything other than they're not getting enough vitamin A. So if you don't have vitamin A, you cannot produce the retinols that you need to be able to see. And so these individuals, or these countries, have a population of individuals that are blind, all because they don't have the proper nutrients. And we've actually produced special rice that contains a lot of these vitamins, like vitamin A and other nutrients, so that when they eat rice, which is oftentimes the only type of food that they have, they're also going to get the vitamins and nutrients that they need. But of course, like I said, because carotene is a fat-soluble vitamin, it will dissolve in that fatty tissue of the subcutaneous layer. And when it does that, it produces that pigment orangish color that shows through the skin. So now we're going to get into the dermis. There are two layers to the dermis. The top layer is the papillary region, and that's the smallest region of the dermis. It's composed of mainly areolar connective tissue. And then the deeper layer here is the reticular layer, and it's composed of dense irregular connective tissue. So in the papillary layer, the areolar connective tissue moves in waves up into the skin, so forms these little waves, or I guess bumps in the dermal layer, which causes bumps in the epidermal layer. Those bumps are, or I won't say are, those bumps produce what we call friction ridges or fingerprints. And so these are fingerprints. All fingerprints typically differ, so you'll never have two individuals that have identical fingerprints in general, unless you have identical twins or, something like that. Fingerprints used to be used to identify potential suspects at crime scenes. They don't use fingerprints as often now. They still use them, but not near as often. But fingerprints are definitely unique to each individual in general. And so we tend to fingerprint our children to make sure that if something happens, we can find them, if they become lost or something, because that is one way to identify your child. And so again, here's that large epidermal or dermal papilla that's causing this epidermal region to have those little friction ridges. So then we have this reticular layer that is composed predominantly of dense irregular connective tissue, which contains lots and lots of collagen fibers that run in multiple directions. So we have protection along multiple lines of stress. Hello, my PowerPoint just disappeared, so I'm going to find it. Sorry. Hello again. I'm going to make sure this is working, so just hold on. Okay, it's working. Everything seems to be fine now. So now we're going to talk about innervation and the blood supply to our integument, specifically to the dermal region. The dermis has nerve fibers, both sensory and motor nerve fibers, that are going to stimulate different functions. So for sensory, we're going to have functions like touch, both deep pressure, light pressure. We're going to be able to feel changes on the surface of our skin. So vibrations are going to send signals. Think about when someone just touches your skin very lightly, or an insect walks on it, you feel that. And then we also can feel things like temperature changes on the skin. So something that's super hot, or if it starts getting cold, we feel that. Motor nerves are going to stimulate the muscles in our integument. So in the dermal region of the integument, we have erector pili muscles that stimulate hair follicles to stand on end. And when we get very stressed or it's very cold, which is a stressful situation, then the erector pili muscles get stimulated and they stand erect so that we can look more fierce, or we can boost the amount of protection from the cold temperatures. We also have motor nerves that innervate our glandular tissue to tell our glands to secrete, both sebaceous as well as our sudoriferous glands, secrete materials to the surface of the skin. We have great blood vessels, both arteries and veins, so we have blood moving to our dermal region and blood taken away. Nutrient-rich blood goes to the dermis and then feeds both the dermis and the epidermis. Within that blood, we also can move heat or other materials that we don't want in our body to the surface of our skin. And so we have nerves that will stimulate our blood vessels to either vasoconstrict or vasodilate, depending on if we need more blood or less blood going to the surface of our skin. So when you are hot from exercise or hot because the temperature outside is extremely crazy, it is right now, but in the opposite direction. What happens is the nerves stimulate our blood vessels to vasodilate. So I'll put that one up there. And then more blood flows to the dermal region, which causes our skin to flush, but it also releases heat to the surface of our skin so that then sweat glands can release sweat, and the sweat can evaporate and pull that heat away, maintaining temperature homeostasis. If, on the opposite side of the spectrum, think about today, or actually think about tomorrow, since today is the day before the Arctic freeze. If you are outside tomorrow for even a minute or two, your body is going to get very, very cold, and all of that heat is going to move to the core of your body to keep your organs that need to function for homeostasis and for maintaining life. And it's going to leave the areas that are not as important, like your earlobes, your fingers. Those are not that important when it comes to survival. And that occurs because nerves cause stimulate the blood vessels to vasoconstrict. So they get very small and blood doesn't flow to that region. The last layer of the integumentary system, even though it's not actually part of the integumentary system, we talk about it here, is the subcutaneous layer. And so this is that fat layer that has a lot of important functions. Mainly, it's a protective area, so it provides protection from temperature changes, great temperature changes. It also protects from blows to the body. So if you're, playing outdoor sport and you get hit by a ball, the fat tissue is going to take some of that or absorb some of the shock from that ball so that the organs that are deep don't get so damaged. Temperature, it provides thermal insulation. So on very cold days, your body can maintain homeostasis more effectively. And it's an energy reservoir, which is why when individuals gain weight, it's that subcutaneous layer often that is increasing in the amount of fat that is in it. I just saw this video or this cartoon and I loved it. So there's your brain saying, yeah, I know it's cold outside, but I'm watching you, fat, because you don't want to gain too much weight just because it's cold out. What is that? A big sweater? So, when we do gain weight, we get bigger clothes. And then, hey, fat, where'd you go? It's hiding in that sweater. Fat? Huh? I just thought it was cute. And so I added it to my to this video so that maybe you can have a little laugh as well. All right, I'm going to stop here because we've covered the dermis, we've covered the epidermis and the dermis, so now we're going to get into the accessory organs of the skin, and then we'll talk about the major functions. So I will see you in our next video. Bye.